night, and they've kind of disappeared every single night. So I don't know if there's some gnomes or whatnot that really enjoy them or what. But what I'm here today to talk to you guys about is OpenStack on OpenStack, which might sound a little bit confusing, but a better way to maybe put it is deploying OpenStack using OpenStack. So as I said, my name's Cody Somerville. I work for HP, particularly our cloud services department. I got to say I have a pretty awesome job. I get to work with some really smart people that are working on something really great, and that's called cloud. Now, we've probably all heard of cloud. You know, not all of us know what cloud is. You know, certainly at the booth, I've had people come that don't know what cloud is, never heard of it. They, you know, maybe think it's iCloud, or people that actually help write OpenStack. So, huge variety of people here at EuroPython, and so you know, some folks see cloud. I mean, it's been an icon that's been used for decades now, oftentimes to refer to ideas or a network without actually depicting, you know, the nuance or the implementation in between. Some people see cloud as synonymous with the internet. It's just a buzzword that, you know, branding exercise by some marketing department that's gone mad. But for those of us that are in the know, we actually know that cloud is something rather revolutionary and something that's rather something exciting, and we call that infrastructure as a service. But if you really think about it, the end goal is still the same, and that's to deploy an application, to make a service available. So maybe cloud is a buzzword. Maybe it's just an evolution of the way that we use the word. But regardless of your opinion on it, there is something very exciting happening and something very cool, and that's revolutionizing the way that we do IT. So traditionally, let's look at traditional IT infrastructure. Let's say your HR group needs a new application or something like that. Maybe they need it pretty quickly to comply with new labor laws or something like that. Traditionally, that's involved a meeting with IT, a PO order, getting that approved by your executives, and getting that shipped to your data center, then racked up, plugged in. Somebody else maybe to install the operating system. Somebody else to work with the vendor to actually get the software installed. Whole process can sometimes take months. It can be even worse if it's a product or a application that's being developed internally, just to get resources to get that going and whatnot for QA and whatnot. A lot of manual work involved. So I have a slide here just as a joke. Remember when provisioning a server took months, which is a real reality. Pepperidge Farm remembers. We've all probably heard the meme to automate all the things. So there's a lot of manual things going on. There's a lot of inefficiencies in the way that we do traditional IT. Why don't we automate those things? We do have a problem. and I think there's something out there that can help with that, and that's the cloud. How does that do that? That's by pooling resources together and actually abstracting those resources away behind an API, and then allowing you to rapidly and dynamically provision, and sometimes even more importantly, deprovision, to give back when you don't need the resources anymore in your data center. It's pretty revolutionary. It's on demand. We're pretty lucky to have something called OpenStack. I'm sure a lot of you have heard of OpenStack. Using OpenStack, we can change the way we do IT, and we can remove that frustration that we've all had. We can provide developers with self-service so that they can get compute or storage resources when they need to. That ultimately means that we're able to better manage and have better continuity of our critical business processes. We're able to get to the market faster, higher profit margins. It's a big net win for everybody. And as I said, it kind of abstracts these resources away. So we have this nice diagram here with some squares or blocks. Compute, networking, and storage abstracted away on top of some shared service, OpenStack shared services, and that's running on top of your standard hardware. And once again, you see application here. It's probably not as big as it should be, because in the end, this is just an advancement of how we've been doing things. It's automation. It's progression. It's moving forward, but it's not revolutionary in terms of the end goal. Certainly helps us get there faster and is revolutionary in that sense, but still just trying to get an application as a service. And One of the neat things about OpenStack is that it's grown in the 3 years tremendously. Everybody wants to get in on it. Everyone wants to get in cloud. And really, OpenStack has kind of become the pervasive, ubiquitous cloud platform. Today, everybody wants, as I said, wants to get in on that. HP is no different. That's why we're one of the top 5 OpenStack contributors. That's why we're here at these events to kind of help increase mind share, and why we donate large amounts of resources to help make OpenStack a possibility. There's more than 1,000 individual contributors, and there's lots of notable users. Everyone's using it. NASA, CERN, AT&T, PayPal, Bloomberg, Comcast, eBay, Sony, Wikimedia, Cisco, some U.S. departments. Not sure what they're using it for, but yeah. So we got all these happy users using OpenStack. But there's one thing that we don't hear people say. Boy, deploying the cloud was so easy. Let's do it again a whole bunch of times. Nobody says that. You saw the diagram there with the nice blocks. It looked very pretty, very simple. But when we talk about deploying cloud, it looks like this. This is the reality. It's very complex. If you think about what we're doing, of course it's complex. We haven't made it more complex than it needs to be. This is just how it is. We have lots of different interactions between services, lots of points of failure, lots of things to configure. You can go and do this. You can install it, and that's really the easy part, is getting it installed. It's not too difficult, but it's the managing it. It's the upgrading the cloud that becomes the real problem and the real struggle for organizations trying to get in on the power of cloud. So, as I said, clouds are great for deploying, large, complex, composite applications. Cloud's a great example of that. So wouldn't it be nice if we could use the same tools and the same APIs to deploy our cloud control layer as we do to deploy applications into the cloud? Wouldn't that kind of be nice? Traditionally, you would have different tools and different processes, which ultimately means that you have a different deployment story for your cloud. That increases complexity, that increases risk, that increases cost. So, as I said, I get to work with some very smart people. One of them is Robert Collins. And under his tutelage, we've been working on something what we like to call triple O. And it's called triple O because there's 3 O's. So OpenStack on OpenStack. What does that mean? What is that? It's more of an idea, actually, than necessarily any kind of new technologies or new tools. It's about reusing the existing powerful abstractions that we have, better manage and be able to better manage our upgrades and maintenance of our clouds, and better installation. So there's some parts of the puzzle, and I want to share them with you. And then once I've done that, you're going to have an idea of how this is actually a reality. So what are the parts of the puzzle? We have provisioning, we have software, we have configuration, we have orchestration, we have state. There are things out there that do these things today. And you can probably use the cloud to deploy them. Use them to deploy the cloud. We've taken a kind of a different philosophy where for each of these points of the puzzle, we've created we've kind of followed the Unix philosophy of creating small, targeted purpose tooling or applications to deal with these problems. So the first one is provisioning. How do we actually, we have the server in the data center. How do we get it from going just plugged in, sitting there waiting, to actually doing something? How do we actually deliver software for it to run? So you look at Nova, which is the compute part of OpenStack. We use that to do something very similar with virtual instances. We use it to create virtual instances, to suspend them, to destroy them. We have this great API, powerful API that abstracts that all the way for us. It doesn't matter what the hypervisor is underneath. It doesn't matter if you're using KVM or whatever. Are bare metal machines really that special? No, they aren't. And there is some special case things, but overall, it's not important. That's why we have Nova Bare Metal, which actually allows us to do this by using IPMA or whatever out-of-bound management protocol you use, we can control the servers in our data center to turn them on and off. And then we can use PXE to boot those servers with some software. What we'll do is when we go to provision a server, we'll send over a small RAM disk that then exports the disk in that server over iSCSI. And then the Nova bare metal deployer is able to write the image from Glance, which is the image registry, to that partition. And then we're able to reboot that server, and we're running an image that we've deployed from OpenStack. That's just part of the problem. We also have to have software to run on there. One of the best practices with cloud is create a disk image, whatnot, and upload it to Glance and deploy it. Not running installers, not doing, some people will do a bunch of stuff at boot. But one of the benefits of creating specific images to run certain services or groups of services is that we encapsulate a known good set of software, a state of software. That provides us a lot of value. We are able to exclude the configuration persistent state so that we can deploy it all across our data center and persist the actual bits that we care about keeping elsewhere. Ultimately, this means that each image can actually be tested and deployed as is. We've actually created a small focus tool chain to help with this problem. It's called the Disk Image Builder, very creative name. It basically takes an existing image, Fedora or Ubuntu, and it then takes something we've called elements. And those are elements that we've created where we've distilled down the expertise of configuring these services and the logic necessary to handle migrations and things like that. And then we bundle them all up and we install the necessary software that's dictated by these elements and install configuration templates and whatnot, which I'll explain how we use those in a little bit, and give us a good image that we can deploy and have it come up and run these services. Now, obviously, there's some questions there about, well, how does it know what to do and whatnot? Before I jump into that, there's the configuration bit. And this is an important part to understand before we get to that really exciting part, which I'm pretty excited to talk about, actually. It's the most exciting part. And we've created another small utility. It's called OS Apply Config. Basically, it combines metadata that's been delivered to an instance from the cloud with templates that we've shipped with the image to produce usable configuration files. So metadata that's delivered from the cloud to the instance allows us to configure the image for whatever purpose we need. As I said, it's a small utility that we've just designed to move forward without tying ourselves to a particular configuration management solution. You can use Chef, Puppet, Salt, whatever you want here if you prefer instead. So as I said, the really exciting thing that I wanted to talk about, and that's Heat. Heat is orchestration. It's a structured, declarative, multi-node, multi-service orchestration service. How many people have heard of CloudFormation? Not too many. So I guess not many people here use Amazon CloudFormation. Basically, it's a way for you to describe the resources that you want to create in your data center and then have the cloud go and make it so. You're able to put in parameters and use that in how you describe the resources you want to create. And you're able to actually, at runtime, get information about those resources and coordinate that information between the different bits and different resources that you create. This is an example template here. For example, we can pass in a key name or the instance type or the DSN for connecting to the Glance database. Information that the minimum really in the examples we've created is the minimum amount you need for the service to come up. But what happens when things change, or you want to upgrade your software? We've created another small tool called OS Refresh Config, and this is triggered by a set of tools that monitor the heat metadata that's sent to a particular instance. And when that happens, it's automatically going to refresh your config. It's going to take care of restarting your services. It's going to take care of coordinating data migration and then signaling completion to heat. It's also able to pass data back to heat. So if we go back to our template here, later on when we're declaring actual resources, we can create a wait condition on a certain resource or we're able to basically just say, we're going to wait on this, and the necessary part is able to signal back that that's good to go, and it can pass in some data such as these are the database usernames and passwords that the different Nova nodes are going to use to access this resource, for example. So there's 4 phases: pre-configure, configure, migration, post-configure. One really interesting use of the migration is for like MySQL. We have a MySQL migration element where you're able to bake that into an image and deploy that, and that'll automatically take care of migrating your MySQL database and setting up replication and stuff like that, and does so without you losing that data, and does so takes care of ensuring that process completes successfully before signaling back to Heat that that process is complete. So what does an initial deployment look like here? So we have Heat, which is driving Nova, which is a compute service, to deliver the software to the bare metal nodes. So with the initial deployment, it's a little bit special. What we do is we use that disk image builder to create a bootstrap node, and we'll probably run that in a VM, maybe on our laptop, and we'll bridge that to the data center network. Next, we'll enroll the machines with Nova bare metal. That's basically just telling them the MAC addresses. And then we call Heat, and we say, Heat, deploy my OpenStack templates. Here's the parameters that are required by these templates. And at that point, you sit back and relax and watch as Heat drives the Nova API to scale out the cloud on your bare metal instances. That was going to bring up compute nodes and all of the rest of the infrastructure. And at that point, those compute nodes that is brought up are part of a cluster that automatically take care of auto-scaling. It'll handle failures and whatnot. And you'll be able to do the actual KVM emulation from that endpoint. Then you switch off the bootstrap node, and at that point, Heat's going to see that it's gone, and it's going to be able to actually respond to that by scaling out again. So there you go. That's pretty simple. Managing your deployment. We've learned a lot about cloud and how that affects managing how our services and whatnot. And we can now take those lessons, thankfully, because we're using cloud to deploy cloud, and apply them to our actual cloud control layer. For example, rolling backwards is just as simple as rolling forward. Simply deploy the old image. We can prevent entropy from creeping into our infrastructure by storing data in persistent state in a persistent volume, and then when we want to upgrade, we just overwrite the the root partition with the updated image. And if it breaks, then you roll it back to the old one. Pretty simple. And when events occur that change our state, Heat triggers will fire and cause a system to respond appropriately and execute your logic. There's also some really interesting new possibilities and practical applications with this. Clouds and clouds, multi-cloud tendency. And why would you want to do that? Well, you can integrate this as a part of your CI/CD infrastructure. Deploy and test your entire cloud in your production-like environment on every commit. That's pretty interesting. Because it's also easier, it means more clouds for everybody. So what is reality? What is science fiction? What problems are left to solve? We can actually do this today. And in fact, we've used this exact methodology that I've described here today in this room to deploy a 20-node compute OpenStack instance. And there is some polish lacking, whatnot, and there's some things that if we actually want to use it in production is going to need to be fixed. But we're working towards that, and that's what we're doing in the Havana release. And it's pretty interesting stuff. And if you're interested in learning more about it, you can actually go to the OOO Wiki. We have a meeting every Monday, and you can actually find the code on OOO and also on StackForge. So thank you very much for coming and hearing about using OpenStack to manage OpenStack. I wish I had more time to actually deep dive for those of you that are interested, but I only had 30 minutes. So thank you very much.
Any question down there?
Thank you for that insight. We deploy probably 3 times a week about 60 to 70 nodes. That's our release. Sometimes we need to roll back. We keep them around for a little while and stuff like that. And I noticed that as soon as I try to build more than 20 or 30 at a time, I get into trouble. And also with regards to heat, when is that going to be more widely available? Because I think it's not yet everywhere in all OpenStack, and this is a bit of a developer preview kind of thing, isn't it?
Mm-hmm.
Can you share some insight on that?
Sure. So for for the first one, we certainly experienced hiccups like that as well, and I didn't have much time to discuss those issues. But one of the issues that we're finding is that is robustness across the whole OpenStack spectrum of projects. There's work that needs to be done to improve the ability to respond to situations where you're not maybe able to connect immediately, or there's a bunch of traffic. We also found that the default configurations in a lot of cases are actually very poor, and we've actually, we may have even been running into some of the issues, specific bugs that you've been running into, and we've been working to fix those as well in the specific projects like Nova or Glance or whatnot. With regards to heat is very interesting. It's very powerful, and I could do a whole talk on it. It's really, like, even you should look at it. It's not just for deploying clouds. It's deploying any kind of large, complex composite application. And you're right, it is sort of more like a developer preview at this point. There's still work to be done on it, but I think about in a year's, we're using it now to do it, but it's not ready obviously for production. And to use it for more like in an actual cloud where you have non-admin users, it's probably about a year's away. Like there's issues with handling failures. If one error when bringing up a stack, which is your cluster that gets created and all those resources, it'll fail the whole stack, and how it responds to those. There's no rolling updates either yet, which is really important. Progressing only, upgrading or making changes to X number or X percentage and checking for errors before continuing. It doesn't do that yet, and those are things that you really need in production. So does that answer your question?
Oh, we are running out of time, so just thank you.